Hi, welcome to tutorial 2.8 part 1. Again, we're naming ionic compounds, but this time we're going to include something called polyatomic ions. That is, ions that are made up of poly, meaning more than one atom. Up to now we've only had ions, anions in this case, that were always a single atom that had gained some electrons. So for example, the anions in the past were nitrite, oxide, sulfite, etc. Now we have a new list, and notice here's a list over here on the right hand side. All of these have more than one atom, typically two nonmetals together like nitrogen and oxygen. They almost always contain oxygen. And they have names like nitrate, nitrite, sulfate, sulfite, etc. So what we want to do is learn to name these, and for now we're just going to look them up so we have some confidence. So we're just going to say, all right, what's Na? I know that. That's the sodium ion. So that would just be called sodium. And then I look up OH. I see it down here. It's called hydroxide. So the name of this compound is sodium hydroxide. For every one sodium ion, that's the positive ion, there's this polyatomic anion, hydroxide ion. So what we need to do for a second is just kind of look a little bit to try to understand what these polyatomic ions are, kind of where they came from, and then go back and just use that to name things a little bit. So I'm going to open up this other folder here, and let's have a look at this. What are these polyatomic ions? So first of all, some ions contain more than one atom covalently bonded. So that hydroxide that we just showed, that's a hydrogen and an oxygen that's covalently bonded, and then it also seems to have an extra electron. These ions are called polyatomic ions. They often are formed from acids, and I'm going to show you an animation of that in a second. And when that's the case, a proton is transferred from the acid molecule to a water molecule, leaving behind this substance, which is this polyatomic ion. The negative ion which remains is free then to form ionic bonds with any positive ion, just like any other anion. So let's have a look at the formation of one of these, nitrate. Okay, so here's a acid molecule. We haven't really talked about acids, but just accept that this thing here is going to be called a nitric acid molecule. And what happens is, as water approaches this thing, it's going to steal this proton from this molecule. It's going to leave the electron behind, resulting in a fragmented molecule, a molecule that is now an ion because the proton has been taken, but the electron has been left behind. So watch it for a second. Here comes the water. Boop, it pops the thing off. The proton only was removed, so this thing now is a polyatomic ion. It's called hydronium. We're not going to really work with that one for now, but this type we will work with, these polyatomic anions. It's the molecule that's left, or the fragment that's left after the proton has been removed. It has a -1 charge because that electron was left behind. It's called nitrate. Let's look at one more example. Here is from sulfuric acid. Here's H2SO4, a covalently bonded molecule. Again, the water is going to come and steal not the whole atom, but just the proton. Here it goes. It's going to come in there, grab the proton, and it's going to leave behind the electron, forming this hydrogen sulfate ion. If the other proton was also stolen by another water molecule, it would be called the sulfate ion. So these are the formation of polyatomic ions, but once we have them, naming them and using them to write formulas is just like what we did before. So let's practice a few of these on here so you can see it. So for example, what if you were asked, what is the formula for sodium sulfate? You'd say, well, here sodium has a +1 charge, that's Na+, I know that one. And sulfate, I would look that up in that table, the polyatomic ion table. And now I know I need to balance the charges, so let's put them like in this box and think about what's unbalanced. This group of atoms has a double negative charge. 2 electrons were left behind on that group. This thing just gave up 1. It just has a single positive charge. This is an unbalanced formula if we wrote it like this. So therefore I need another sodium ion. Now they're balanced. I have 2 +1 charges balanced with a double negative charge, and therefore the formula can be written as Na2SO4. Let's just try one more, because right now in this tutorial we're just naming things. We're not trying to write formulas. I'm just trying to get you a sense for where these compounds are coming from. Let's try aluminum sulfate. Aluminum has a +3 charge, if you look that up on that periodic table. Sulfate we just had was a -2 charge. Let's put that in the box and say, well, how can we get these charges to balance? Right now I can see I have 3 pluses and 2 minuses. That's not balanced, so I need another sulfate. But when I get another sulfate, I have 4 minuses, 2 here and 2 here, and only 3 pluses, so that's not balanced. I need more aluminum. Now I have 6 pluses and 4 minuses, still not balanced, but finally, when I get that third sulfate, 6 minuses balanced with 6 pluses. So I found the formula for aluminum sulfate, and the formula would be Al2SO4 sub 3. Okay, so this is just how to actually write the formulas, which we're going to do in the next tutorial. But what we want to do right now is just name them. So I think that's a little bit more straightforward. So let's go back to this chart and have a look at a few more examples. All right, let's look at this one here. CaOH sub 2. Yeah, I can tell the calcium has a +2 charge, each hydroxide -1, but I don't really have to worry about that right now. I just need to name it. So what's this first one called? Calcium. What's this OH called? I look for it here. Hydroxide. The fact that I need 2 hydroxides per calcium does not show up in the name. I just say calcium hydroxide. Some people make a little bit of a mistake here because they've seen it on, say, boxes of cereal or whatever, that this might be called calcium dihydroxide. We're not going to do that here. We're just going to simply say the cation is calcium, the anion is hydroxide, and that's all there is to the name. Let's try another one. How about this one? Well, the same thing. Calcium, and I look up NO3. I don't care about the 2. I realize I need 2 nitrates for every calcium, but for the name, I just look up what that NO3 is. It's nitrate. So that is calcium nitrate. Let's look at another one, CaCO3, calcium again, CO3 this time. Where is it? Oh, there it is down there. It's called carbonate. So this is calcium carbonate. And notice I'm kind of drawing these pictures as you go. I've kind of color-coded them so you can see what the colors matching the kind of charges so that you kind of see how they go together. But we'll look at that more next time. So 1 calcium with 1 carbonate is calcium carbonate. A few more. Na2CO3, Na, I know what that is, sodium. The fact that there's 2, I don't say like disodium. I know there's just 2 sodiums there, but I just say sodium. That's the cation. And then I find CO3 as carbonate. So that's called sodium carbonate. One last one, K3PO4. This is called potassium, as we know from here. There's 3 needed for every 1 phosphate, and phosphate is sitting right there, so I know to name that potassium phosphate. You can click through the rest of these by yourself, and just if you need to practice. Otherwise, practice on the quiz, and we'll just do it together in class. I hope this is making sense. There's nothing new except that the anions themselves are polyatomic and have to be looked up in a chart rather than on the periodic table in order to find their name. All right, good luck with that, and we'll practice together. Thanks.